Alright guys, welcome back to Underground Science, and in this video we'll be looking at an example of balancing a redox reaction, alright, in acid. Okay, so this is going to be in an acidic solution. Alright, so let's go ahead and jump right into it. Alright, so this is our example that we're going to be looking at today. Alright, so it's going to be the dichromate anion. Alright, so I'm going to go write that down. This is the dichromate, the dichromate anion. All right, it's an anion because it has a negative charge of -2, and then we have an iodide anion. All right, reacting with an iodide anion. So this is going to be our iodide anion. All right, and both of these are in an aqueous solution, and both these are going to react, and what's going to form is we're going to have a Cr3 plus. All right, and we're going to have iodine. All right, diatomic iodine. All right, with no charge. Okay, so and let me go ahead and label these also as this is going to be an aqueous solution for our diatomic iodine, or our iodine gas, or I just said the answer. This is going to be in our gaseous state. All right, so now let's go ahead and balance this redox reaction into in acid. All right. So first of all, we have to know what a redox reaction is. Just a short way of saying a reduction oxidation reaction. All right. So you can see reduction oxidation reaction is a long way of saying a redox reaction. All right. So a redox reaction is a short way of saying a reduction oxidation reaction. All right. So, and we'll see why it's a reduction oxidation reaction. So by the name, you can already tell that something's going to get oxidized, right? Hence the oxidation, and something is going to get reduced, hence the reduction. And it's a reaction. All right, so let's go and see how this works. So first, when we're balancing a redox reaction, and if it's in acid or in base, we'll cover in a future video, right? First, what you do is you write your half reactions first. All right, so because you can't balance it like this as of this moment, first let's go ahead and write it into half reactions. So our first half reaction, it's not a full reaction, we're separating this into two half reactions. So our first half reaction we'll write is our dichromate anion with the -2 charge, right? And it's going to be converting into our Cr3 plus, right? That we said over here. And that's just one half reaction, right? So Cr3 plus aqueous state. Right, so this is our first half reaction, right? Let's write our second half reaction. We can't forget about our iodide anion converting to iodine gas, right? Diatomic iodine. All right, so let's go and write that down now. In a different color, let's differentiate the two different half reactions. So we said iodide anion. Go and fix that I real quick. Iodide anion turns into iodine gas, or diatomic iodine, you could say. All right, so now that we have that, our next goal in balancing a redox reaction in acid is to balance the actual atoms out, right? Because remember the law of conservation of matter, matter isn't just lost like spontaneously, like randomly, right? We have to have the same number of atoms on the reaction or the reactant side as we do on the product side. So we have to balance our reaction out, but we have an exception for oxygen. We have to balance using water, and then for hydrogen, we just balance using hydrogen cations. All right, so let's go and look at that. So if we look at our first half reaction, right, dichromate turning into Cr3 plus, we're going to see that we have two Cr molecules right here and only one Cr molecule here. So that means we have to put a 2 on the right side, right? So let's go and put that in a different color. Let's go put that in blue or red. Let's do red. So 2 on this side, because now once we put the 2, we're balanced. 2 Cr molecules here, 2 Cr molecules here. All right. Next, we see oxygen. Remember that was an exception. So let's go and write that down, like just to remind us, short keywords, right, is the key to remembering. So we're going to write exception. All you have to remember, is just remember the word exception, and remember there's an exception for oxygen and hydrogen, all right? Now, the exception for oxygen is that you use water molecules to balance the oxygen on one side. So if there's 7 oxygen molecules here, right, because there's the 7 right here as the subscript number for oxygen, there's 7 atoms of oxygen on the left side. How are we going to get 7 atoms of oxygen on the right side? Well, we're going to add 7 water molecules. Now let's see what that's going to do, right? So we're going to add 7 water molecules. All right, and this is going to be obviously liquid. Now that we have done this, right, we added 7 water molecules. Now you can see that we have 7 water, or 7, we do have 7 water molecules, but you can see we have, in specific, or in particular, we have 7 oxygen molecules here and 7 oxygen molecules here. But we have another problem now. We have 14 hydrogen atoms here, right? 7 times 2, which is 14 hydrogen atoms, not items. But we have 0 hydrogen atoms here. So how do we balance that? Well, let's scroll down and rewrite it. All right. So again, let's write our half reaction that we're trying to balance right now. Right. Dichromate with the -2 charge in its aqueous state. Let's just go and write it down right now. Okay. So aqueous state, let's write that better. Okay. So we just said that we have 14 hydrogen atoms here, but 0 here on the reactant side. Remember this key word, right? Key phrase, you could say exception, O and H. Oxygen, we just solved that exception by adding 7 water molecules. Now the H is another exception. Well, I mean, now it's not exception, right? We have 14 hydrogen atoms here. So what you're going to do for H is you're going to add 14 hydrogen ions on the left side also, right? Hydrogen cations. So it's going to be dichromate anion plus 14 H plus ions, and then we're going to have our arrow, and then the rest of the atoms are going to stay the same. Okay, so what do we have on the right side? We still have our Cr3 plus. How many? We have 2 Cr3 pluses, right? 2 atoms of Cr3 plus, aqueous state, and then we have, let's squeeze this in, 7 water molecules. All right, and these 7 water molecules are in its liquid phase. Okay, so now this specific half reaction that we started with is for temporarily balanced, right? We have 14 H pluses on this side, or 14 hydrogens, and we have 14 hydrogens here. We have 7 oxygens here, and we have 7 oxygens here, and then we have 2 Cr3 plus atoms here, and we have 2 Cr3 plus atoms here. Perfect. Okay, now let's work on balancing this half reaction, iodide anion to iodine gas. Okay, same thing here. First step, we already got into a half reaction. All right, now we have to balance the atoms, and remember this key phrase, exception O and H. Okay, so we have an exception for oxygen and hydrogen when it comes to balancing. But the good thing is we don't have any oxygen and hydrogen here, so we don't have to worry about that. We just have to worry about balancing atoms in general, which is pretty easy here because we have 2 iodine atoms here, and we only have 1 iodine atom here, so we just add a coefficient of 2 to make it 2 atoms of iodine on the left side. All right, so actually, sorry about that. Let me go ahead and actually make it more clear. Let me write that a little smaller and then add the 2 here. So now both sides are happy, right? We have 2 iodines here, 2 iodines here. We're good. Now comes the part where we look at these 2 reactions, right? We look at these 2 reactions and we see what the amount of charges on both sides, okay? What I mean by that is this. Let's look at iodide to iodine gas first. All right, so let's go and write that down. Rewrite that, I guess you could say. So 2 iodine molecules here, right, iodide, and then we have, it's in its aqueous phase, and we go here, and then we have 2 iodine molecules here on the right, or the product side. All right, so now we have to see the number of, or the amount of charges on each side, and we have to balance the charges now using electrons. Okay, so let's go and write that down. So now the next phase is to balance with the use of electrons. All right, so with electrons, and we're balancing the charge. Okay, so let's go ahead and make that clear. We're balancing the charge on both sides. All right, so how do we identify that? Well, we have a negative charge here, right? Iodide has a negative charge of -1, and we have two of these. So our total negative charge on our left side is -2. All right, that's our total negative charge on the left side for this half reaction right here. All right, for this half reaction, it's -2. Look on the right side, we don't have any formal charge on iodine gas. So our total charge on this side is just plain 0, right? We don't have any charge. Now to balance this out, again, we have to add electrons to balance out the charge. So what we're going to do is we're just going to add 2 electrons on the right side. So let's see, look what it's going to do, right? So if we add 2 electrons here, now on the right side we have 2 negative charges, which is -2 now, and we also have a -2 here, right? So the total charges on each side of the equation, on the products and reactant side, are equal. So we're good. So let's go ahead and write that out neater, right here. So 2 iodine molecules right here, or iodide anion, right? It goes here. And then we have our balanced charged, I guess you could say, equation of by adding 2 electrons to the right side. All right, sweet. Let's look at our dichromate reaction above, all right? So over here, we look at the same thing. What's the total charge on the right side of the equation? Well, all I see here is a 3 plus, but multiplied by 2. So the total charge on the right side is 6 plus, right? A plus 6 charge on the right side, the total charge. What's the total charge on the left side? What I see here is 14 plus charges, right? 14 plus 1 charges, but 1, 2 minus charge. So 14 minus 2 is 12. So we have a plus 12 total charge on the left side. All right, now how do we balance this out? Well, all we have to do is add 6 electrons on the left side of the equation, because 12 minus 6 will equal 6, and then we'll have charges balanced on the both sides of the equation. So let's go ahead and rewrite that and see what we mean. So let's see, we'll write out dichromate, anion, right? Like this, aqueous. We'll leave some space for our 6 electrons later, right? So our 14H plus here. And then just going to write it all in one color now so we can save time. Then we'll have 2 Cr3 pluses in our aqueous state. And then we'll have 7 water molecules in our liquid state. And again, we have a plus 6 total charge here at the moment, and we have a plus 12 charge here at the moment on the reactant side. To balance this out, we just said that we would add 6 electrons on the left side. Now, 6 negative charges, if you add that to 12 positive charges, you're going to get a net total of not plus 12 anymore, but 12 minus 6, which is a plus 6 total charge on the left side. And see, we matched. So both sides are happy with charge. All right, so now that's over with. We have a couple more steps left, right? Our next step is going to be to balance out both of our half reactions that we started with, right? Which are this one right for at the moment, and this one, right, that we just talked about. We have to balance the number of electrons. Okay, so as you can see, if we add these two reactions together, right, this half reaction and this reaction right here, half reaction, it's not going to be equal because we have 2 electrons here on the product side, but then 6 electrons here. So we have to figure out a way to make the number of electrons equal. All right, so to do this, look at the half reaction that has less electrons on the other one, which is this one, right? This only has 2 electrons on the product side, while this has 6 electrons on the reactant side. So all we have to do is just multiply everything here in this half reaction by 3. So watch this. Let's see what multiplying by 3 is going to get, right? What that's going to do for us. So then if we multiply this whole thing by 3, right? We multiply everything by 3, we're going to have 6 iodine, right? 6 iodide molecules here. And then we're going to have 3 iodine gas molecules, right? Because 3 times 1 is 3 and we're going to have 6 electrons because 3 times 2 is 6. All right, so 6 electrons. Now look what happens. So if we write this dichromate half reaction out, right, or so that's going to be Cr2O7, and we don't do anything to the dichromate half reaction because if we do, then we're not going to have the same number of electrons on both sides, right? So if we keep the dichromate reaction the same, right, this half reaction the same, we're going to get plus and then 6 electrons, right? We're just keeping everything the same, okay? So we're just rewriting this below so we can see if it's equal or not, if the number of electrons are equal, so we can add it together, add the two reactions together, all right? And then we're going to have plus our 14H plus atoms, all right? And then we're going to go here. We'll have to squeeze it in again. All right, we're going to have 2 Cr3 plus atoms, and then we're going to have this in the aqueous phase, and then 7 water molecules in our liquid phase, okay? And so now you can see if the whole goal of balancing these redox reactions, right, is to add them together at the end. So we're at the last stage, right? We're about to hit that touchdown, okay? Okay, never mind. That didn't make any sense. But okay, so we just have to add these two half reactions together now. This half reaction and this half reaction. Now the reason we didn't add it up here again is because we didn't have the same number of electrons for the both half reactions, right? We had 2 electrons here on the product side for the iodide half reaction, and we had 6 electrons here for the reactant side on the dichromate anion half reaction. We can't add it together if you don't have equal number of electrons. So then what we did, we multiplied everything by 3 in the iodide half reaction, which made this 2 electrons turn into 6 electrons. And now both of our equations are happy. We're ready to add, okay? Because we have 6 electrons here, 6 electrons here. All you have to do now is just add. So if we add these two half reactions together, we're going to get this. So actually, let's just go to a different page because we're running out of room. All right, here we are. So we're on another page now. So, all right, now we have to add these two reactions together, right? Add these two half reactions together. So let's go ahead and do that. So now we're going to start off by adding the reactants of the both half reactions together, right? So all of this, okay? So we're going to add 6 iodide molecules. I'll try to be consistent with the colors. Okay, and then we're going to add our dichromate anion. And then, let's see, we're going to add our 6 electrons. Okay, so that's it for the for the reactants. And then we're going to add, okay, I don't know where the arrow went for this. But then we're going to add the products, okay, of the both half reactions. So all of this. So then what's that going to lead to is 3 iodine gas molecules plus the 6 electrons. Crap, I don't think I'll be able to fit it right here. Plus 2 Cr3 plus molecules. Then, sorry about this, but I'll just have to squeeze it here. 7 water molecules. Okay, so now that we have this, we're almost done. Okay, we're almost done. Now that we have this, one thing we notice right off the bat is that we have 6 electrons here and 6 electrons here. Now in a regular equation, if you brought the 6 electrons to this side of the equation, you would be subtracting these 2 electrons. So right off the bat, we can just get rid of these 6 electrons, right? Because it's a common between both sides of the equation. So what we're going to be left with is, again, 6 iodide atoms plus a dichromate anion. The 6 electrons are gone, right? And we can't forget about the 14 protons or 14 hydrogen cations. So we have our 14 hydrogen cations here. And then we go ahead and add our product side of the both half reactions, right? And that's going to yield 3 iodine gas molecules. 3 iodine gas molecules. We're going to have our electrons are gone because we canceled it out because we had 6 electrons on both sides. Then 2 Cr3 plus molecules. And last but not least are 7 water molecules as liquid phase, all right? And guys, that's pretty much it, right? We can double check again. if we followed our law of conservation of matter, right? If we have the same number of atoms on both sides. So let's go and check that real quick. Let's start from the beginning. 6 iodine molecules, good, right? 6 iodine molecules here. And we have 6 iodine atoms here. Okay, so iodines check, we're done. 2 Cr atoms here, 2 Cr atoms here, done, right? 7 oxygen atoms here, 7 oxygen atoms here, we're done. 14 hydrogen atoms here, 14 hydrogen atoms here, we're good. All right, so that's it. So this right here, right, we finally finished balancing our redox reaction and acid together, right? So let's go and write this down. This is our balanced redox reaction in acid, all right? Let's go and highlight that out, in acid. Now, why I'm saying in acid, the reason I'm saying in acid, guys, is because there's a thing where you balance redox reaction in base too, okay? And we'll cover that in a future video. Pretty much, if you got this down, you'll get that down pretty easily because it's pretty much the same thing until you get to the end where you add OH hydroxyl groups on both sides, and then you do a few more steps, and then that's balanced redox reaction in base, okay? But hopefully this video made sense to you guys. And in the next video and in my future videos, I'll be talking about topics related to chem, biochem, physics, and bio. And so I really hope to see you guys there in my future videos. Make sure to hit that notification bell so you know when I'm publishing my future videos. And yes, see you guys later. All right, and stay safe.